8th graders. It's Mrs. Thompson. We're going to cover our very last example in 8.2. It's an application, and hopefully what we've learned in this particular section about vertex and axis of symmetry is very useful and helpful to you. And here's a great application. Some of you are asking me, when are we ever going to use this stuff? When are we going to ever use it? Well, not everybody does, but people like engineers who have to build bridges or roads, they need to know this kind of stuff because they might use arches or any type of support like that in their construction, and they just have to be able to know something about quadratics to help them. So let me show you an application where quadratics are useful in real life. Here it is. The height above water level of a curved arch support for a bridge can be modeled by f of x equals negative 0.007 x squared plus 0.84x plus 0.8. X is the distance in feet from where the arch support enters the water. Can a sailboat that's 24 feet tall pass under the bridge? Okay, that's what we're wanting to know. So we have plenty of information to determine that. And what you may want to do is draw yourself a picture. We're talking about a curved arch support. So I'm going to kind of just draw a real basic, kind of a crude drawing of a bridge with a curved arch support, okay? So some really smart engineer, not me, came up with, used good math and came up with this bridge concept. We've got to cross over a body of water, okay? So here's our H2O. This is our bridge. And we want to know, can a sailboat come underneath that bridge safely if the sailboat is 24 feet tall? That's what we want to know, okay? Sometimes drawing a picture can help you visualize what you need to see. Now, when I drew that curved arch support right here, did you happen to kind of all of a sudden in your mind's eye go, wait a second, that's a parabola? I've been studying parabolas, and I hope that's what happened. Parabolas are all over the place. If you play sports, that entails throwing a ball or hitting a ball or striking a ball in any way, you are using parabolas then, okay? So let's take a look. We have a parabola here. It's opening down. So we have a top point right here. That would be our vertex, right under the G in bridge. That's our vertex, okay? Now when boats go under a bridge, especially really super tall ones, they want to go under the bridge at its highest point. The reason is because if they don't go under the highest point and they're pretty tall and it's going to be a kind of a tight squeeze, they may hit that bridge and damage it, damage the boat. All kinds of things could go wrong. So we want to make sure that it can clear, and that sailboat's going to come under the bridge at its tallest point, and the tallest point is the vertex, okay? So kind of imagine that the water, that's your x-axis, and then the height of the bridge is your y-axis. That's how I want you to imagine it. Kind of see that xy coordinate plane there, all right? So I need to know specifically the height. So I need to know the y. But the only way I can find the y is if I know the x of that vertex. So remember, we just did a strategy last example on how to find the vertex when all you know is an equation. It's okay that we don't have a specific and exact graph. It wouldn't have helped us anyway. It probably wouldn't have been exact anyway. So on the grid intersection. So what we're going to do is we're going to use these numbers. Negative 0.007 is our A, 0.84 is our B, 0.8 is our C. Not that we need C, but I'm going to identify it just for all intents and purposes. All right, so we're going to use the axis of symmetry formula, which is negative B over 2A. So we're going to take the opposite of B, which is negative 0.84. and we're going to divide that by 2 times A. Well, A is negative 0.007. Okay? You're going to need a calculator for this. Those are some pretty tough numbers. So when you calculate it, you should end up with your x equaling 60. Okay? So what we're doing, we're looking for the vertex. Don't really need to know the x, but we do and are interested in the y. Okay? And to get to the y, we have to know the x so we can plug it back in. So now what we're going to do is we're going to take that 60 and we're going to plug it in wherever we see x. So you can do this right in your calculator. Negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8. You can do that all in your calculator, okay? And when you crunch those numbers, you're going to find that y equals 26. So your vertex is at 60, 26. The number you are most interested in for the height of that bridge is the y, because y is how tall that bridge is above the water. So the height of the bridge is 26 feet tall. Can that sailboat safely pass under a 26-foot bridge at its peak if it is itself 24 feet tall? And hopefully you said, yes. Yes, it can. Can a sailboat pass under the bridge? Yes, because the bridge is 26 feet tall at its peak, which I didn't write, but that's the truth of that. Okay? So there's the first example for 5. The second one's real similar. Okay? Height of a small rise in a roller coaster track is modeled by, and they give you an equation here. You're going to need that. And then X is your horizontal distance in feet from a support pole at ground level. Find the greatest height of the rise. Remember, height will be your y. So again, you're going to do this problem just like the first one I did with you. This will be extra credit, 1 point if you can tell me what the greatest height of that rise is. Okay? So good luck with that. Bring your questions to class.